look at it as a tool in your tool belt. Figure out what the best use is. Educate your folks on it, and keep up with the whirlwind that's going on in the cloud native space. Because Kubernetes is really going to give you that freedom to pursue your customers wherever they are and deliver a product that is effectively, to put it another way, nobody's paying you because you're the best at CI/CD or you're the best at orchestrating VMs. People are paying you for your product. So take advantage of what's already out there that can help you make your product the best that you can make it.
This is Sovereign DBaaS Decoded, a podcast for IT leaders and implementers looking to reliably scale database ops while maintaining control of their data stack. In each episode, we join industry experts to discuss the what and why of sovereignty and how you can implement the Sovereign DBaaS concept of your own using open source databases, deployment models, and tooling. Let's get started.
Hello and welcome to another episode of Sovereign DBaaS Decoded, brought to you by Several Nines. I'm Vinay Jusri, co-founder and CEO of Several Nines. Our guest today is Eddie Wassef, Vice President and Chief Architect at Vonage. Thank you for joining us today, Eddie.
Thank you very much. Pleasure to be here.
So, Eddie, can you tell us a little bit about you and what you do?
Absolutely. So I'm currently the Chief Architect and VP at Vonage and Ericsson Company, and my role is really evolving the architecture, looking at cloud native technologies and looking at ways to adopt new patterns and practices and engineering disciplines to evolve our architecture. We're in the business of being on the cutting edge. We're in the business of communication, and you do not want technology to be a roadblock for that. So me and the team, we kind of investigate and we make the hard decisions of how much technical debt we're going to take on with any new technology, and we present it to the company.
Yeah. So I guess, telecom, 20 years ago, a bit more than that, I was at Ericsson, and I guess availability is still a thing for telecoms.
Absolutely. Availability. I mean, you think that, a drop call is just a drop call, but sometimes you have emergency calls or you have these really critical situations or situations like what we're in. We're recording something live. It could be a broadcast for a podcast or it could be a live broadcast. All of these things require, several nines of availability and reliability there. So it's all about being able to have the redundancy, being able to have the fallback, but still not be a dinosaur, still be at the cutting edge and take advantage of all the innovations that are coming out.
Yeah. And I guess, being in telecom is, it's been at the forefront of, tech in a way. It's always been, a highly technical industry, and maybe not as, let's say, conservative as other industries, right? So Kubernetes, what's the adoption of Kubernetes like in within telecoms?
Well, I mean, Kubernetes is an amazing tool set. It's an amazing orchestrator that solves a lot of problems. And, telecom is a very broad, industry. And there are areas that are very much risk averse and are still require the bare metal capabilities. And there are still, even building sometimes your own OS to manage the metal. But in other cases, all the software on top of that has seen an amazing adoption of Kubernetes. You see things on public clouds, working with the cloud vendors, working with smaller cloud providers, and even working with the private clouds, or what you call edge clusters as well. So it really solves a problem because it brings you that common baseline and allows you to have a common language, if you would, a universal language of how to deploy your application, how to manage your applications, and how to service your customers. And so there's been a huge uptick in it. It's not an easy, tool to master. So there's been a lot of variety, but I think with the advancements, a lot of things are moving in the right direction.
Right. So, this talk is about, Kubernetes and databases. And I know you are a Kubernetes advocate. So give us the elevator pitch. Why would I run my databases on Kubernetes today?
Well, that's the one that I've been asked quite a few times, right? And the answer is why wouldn't you run your database on Kubernetes? Kubernetes gives you the ability to forget about everything that's below your application. You don't have to, just like we stopped worrying about bare metal when virtual machines became the norm and we had that standard. You don't even have to worry about storage. You don't have to worry about networking, and you don't have to worry about the monitoring and resiliency. Kubernetes gives that to you, and it's been cutting its teeth on stateless applications for years. And data has kind of lagged a little bit behind, mostly because we had a monolithic application and a monolithic data store, and things were very much tuned for each one. But as the monolith on the application side has started breaking down, we need to start breaking down our data into micro databases and take advantage of all of the elasticity, the observability, and the declarative nature of deploying these things that Kubernetes gives us, and put our data on there. There's no reason why your database can't elastically scale both, vertically and horizontally. Kubernetes gives you that, and we should take advantage of it.
Right. So let's look at the landscape in terms of environment and workload, right? So we know that Kubernetes was born out of the cloud operating model, right? Which historically has been tied to public clouds. Now, is that still the case? Or do we see more on-prem infrastructure adopting Kubernetes?
You see a lot of on-prem, as they call them, edge clusters that are coming out because of data sovereignty, because of the geopolitical landscape, and just because, honestly, I think Kubernetes has commoditized a lot of cloud native technologies to be able to come into your data center. Before, if you wanted any kind of PaaS systems, you had to pick the right, cloud provider that had what you needed, and you kind of stuck with them. But now the business landscape, the world's gotten to be a smaller place. I mean, we're speaking right now, across half of the world, across the Atlantic, and that's how our customers are. So maybe in the country that we're trying to service customers, that cloud does not exist. So now I have to be in multiple clouds. In other cases, there are no clouds. I mean, there's still not a data center for AWS, Azure, Google, Alibaba, so on, in every country in the world. What if I have customers there? And so you start seeing a lot of these, maybe bespoke vendors that create the private clouds, or you have other software providers that give you Kubernetes as a service, or PaaS, that you can install your systems on top of. And that's a great thing, because now you've got a common layer that I can run the same service, the same quality of that service on any cloud, or in my data center, or in my home lab.
Right. So then that's, so I guess it's like this common denominator in multiple environments. Now, moving on to workloads, right? And I think you kind of alluded to that earlier. Looking at how workloads on Kubernetes have evolved over time, it was originally designed to run stateless, right? And I'll be honest here, I have been very, very skeptical about running databases on Kubernetes. I remember the early days that put me off. You'd have a new version every month, and it was hard to build something on something which was constantly changing, right?
Yes.
So, but today, as you advocate, right, it is increasingly sort of used to run databases and other stateful workloads, right? We do see, organizations even moving, existing databases on Kubernetes, right? So, in your opinion, what was the initial issue, right? And I think you mentioned there that one of it was mainly the database as a monolith, but there must be other things, right? And how has that been resolved? And has something, fundamentally changed?
Well, with Kubernetes jumped into the orchestrator world, I would say, with a lot of incumbents. And so to get adoption, they really had to meet the service fabrics and the cloud foundries and all these other, the TIBCOs and the big service bus models. And there was a lot of churn because, it was born out of an existing project. To become a mainstream project, there was a lot of movement that happened. Docker was still relatively young. The APIs weren't necessarily stabilized, but as it matured, it has really done a good job I wouldn't say is slowing down, because there's still a release every quarter, which is amazing. And that's one of the things I actually like about Kubernetes. But they've managed their backwards compatibility and their API structure really well. They've also created, I think, the key extension points, allowing developers to create custom resources and to create operators to extend Kubernetes and effectively codify their platform engineers or their day two engineers into the clusters itself. So I think from a product, it's matured. It's absolutely, everything runs on it today. So it's very much a prime time. But I would say the biggest changes that had come to Kubernetes that helped the data side was, things like stateful sets, things like the adoption of storage classes, the integration of CNIs and CSIs onto the containerization platform using Containerd, especially. And so that allowed some of the things that are specific for stateful workloads to be applied. Things like having a consistent network name, right? Being able to consistently reach a particular pod or a particular storage that's attached, that you really didn't care about in a stateful set. In a stateless application.
Right.
So before if you had let's say a MySQL cluster and that service went away and then showed up somewhere else on another machine, things wouldn't work. Right. And so now they've, not now, but with stateful sets, you can guarantee that at least it'll look the same on the network. It'll be attached to the same storage that it had before. And so it's effectively like you just restarted the process. Right. And so that helped a lot. And vendors took advantage of that. We saw a lot of new SQL vendors come out, which are kind of the hybrid between relational and document store, column store, vector, so on and so forth. And take advantage really of some of the best of the stateless world, like Raft protocols and consensus and so on, but still give you the atomicity and the ACID nature of like relational or something else. So it's really been evolving and it's building on top of each other. This house of cards from Kubernetes to the vendors, and they built something that took advantage of Kubernetes. They saw an advantage and so on, and it's really elevated the bar across the board.
Yeah, and we can see, there's huge organizations, but even pretty much all the database vendors have released their operators for their databases, and that's a blueprint way of operating.
Getting there, absolutely.
So I saw your talk at KubeCon. I've been watching a bunch of your talks there. Very, very sort of educational for me, and I really love the way that you described some of the Kubernetes components involved in the persistent storage, right? And that's in terms of Marvel characters. So, for the benefit of our audience, can you give us an abbreviated version of that? And, where you demonstrate, the sort of feasibility of running databases in Kubernetes into those tabs.
Absolutely. First and foremost, thank you so much for your kind words. I appreciate you going back and watching it. I encourage all of you all to take a look at it. It was a really fun experience for me and hopefully very educational for you. The gist of it is, when I look at Kubernetes, it's a big, wide world of structures and concepts and things that are very difficult. And I try to relate it to something that is easy for me to digest. And therefore, this is kind of where this whole Marvel universe came from. And so I look at Kubernetes like the Avengers, right? And they are there to save mankind from whatever it is, whether it's Thanos or so on and so forth. They can also destroy your city, right? Which Kubernetes has done in a lot of cases. But, if we look at the Marvel characters in the Avengers, you have your well-known characters. You have your deployments, which are like, maybe Captain America or Iron Man. You have your replica sets. These are things that have been known that they got all of the, I would say, all of the clout in all of the publications, right? They do a great job at scheduling workloads, stateless capabilities, but they treat everybody as equal, right? There's no personal connection that's created. And so, I look at how data is on Kubernetes using concepts like persistent volumes and storage classes and stateful sets, and I see in my mind the Guardians of the Galaxy, which are kind of like the quirky Avenger types. And in this presentation, I kind of relate Starlord to a stateful set, and a group to a persistent volume, and the Rocket Raccoon to your storage class. And abbreviated version. Star-Lord is an Avenger, but he does create a personal connection with everyone he's trying to save. He gets to know their name, which is similar to how stateful sets provide an actual name, not just some hash to the pod. And that way, even if it moves around, it's still referred to by that name, which is something that all databases or data applications need to know. They need to have that network identity. And they also keeps them in the same place the longest. They don't want them to get up and move. And because Star-Lord was an orphan and he was stolen by the Ravengers, I know we might be getting a little too deep into the Marvel lore here, but he understands what it's like to have a place to call yours, even if it's a small place. And so they do that with pods. They let the pods stay there as long as possible instead of moving them around whenever there's a scheduling event. Persistent volumes, these are the elastic storage capabilities inside of Kubernetes, and they can effectively grow or shrink. You can take snapshots, and just like Groot, where you can have a little baby Groot or a gigantic Groot that kind of grows as you need it. If Groot is destroyed, you can take a little piece of him and grow him again, and it comes back. You can do that with snapshots and so on inside of persistent volumes, persistent volume claims. But you can't really understand Groot. You have to have that special language. And Rocket Raccoon is that translator, the universal translator. And that's kind of where storage classes come in. They give you a very simple, what do you want to do to the storage? I want to attach this storage. I talk to the storage class and so on. So that was, the very abbreviated version of the talk. Please do take a look at it. It was a lot of fun to do, and hopefully I kind of got the idea across there.
I would definitely recommend, watching that talk. That was last November. And because I thought it was a very down to earth, kind of description and stuff you can relate to, because otherwise infrastructure can get so dry and boring, and especially when you're trying to learn some new big framework. But I think making these comparisons it puts a lot of life into this, and it does get interesting. So.
Yeah, I think software in and of itself is a model of, we're trying to model how our life works in the real world, but in computers. And everything, regardless of what you name it, has some parallels in the real world. But if you can make that, connection, it'll really hit home for you.
Yeah. So let's see if Kubernetes is right for you. One of the most popular way of running your database today is public DBaaS, right? Amazon RDS, Cloud SQL, and I guess the reason is organizations, they hate databases, right? It's the DBA teams are kind of special in a way. Traditionally they didn't collaborate that much. Whenever you were building applications, you had to go to the database guy or girl and actually get a database and try to find a way to model your data, but with DBaaS, I mean, you still have to model your data, but in a way you can just click and then you've outsourced the problem. You click and you get a database, and all the life cycle kind of thing is taken care of, right? So you give it to somebody else, and I guess that's been a big advantage, that convenience that companies have gone to DBaaS, and so DBaaS, I guess it's supposed to be the low ops choice, right? Taking care of deployment, maintenance, tasks like backups, patching, scaling, or is it?
Well, I mean, it's closer than the old days, like you said, where you had the folks that were really taking care of your crown jewels. I mean, your data is your gold, and you need to make sure that it's there, it's secure, it's available, and that's why we had the gatekeepers or the DBAs back in the day. DBaaS promised that, but I think they stopped short of really taking that turnkey. So sure, you can provision hardware and you can provision the service out in the cloud, but 9 out of 10 of them are not going to set up your security groups. They're not going to treat your do any kind of backup for you. They give you the tools to do it, right? But they're not actually going to take that from soup to nuts. So as an organization, you still need to have someone who has some knowledge of data on what your data is going to do and how you're going to store it and maintain it. And the number of times that I've seen where somebody forgot to turn on snapshot backups, and then a disaster happens, because you never really know or have an issue with it until something bad happens. And then you go back to the vendor and they're like, well, you didn't click that checkbox when you were supposed to. And then that becomes, bad taste in the mouth, and they have to pay for some kind of recovery. I think it's because data is not easy. It's a very hyper customized kind of discipline. But I'm pretty disappointed. I think the DBaaS world has not been the promise that we've all been promised. I'm personally not a big fan. I'm much more of a put it on Kubernetes aspect, but I understand the value that customers see from DBaaS. But I would argue it is not the turnkey solution that it was promised.
Yeah. And this is kind of a little bit, coming to the next question here, which is, what is the role of DBaaS in a Kubernetes world, right? Would Kubernetes operators would be a viable alternative, right, to run your database anywhere? The thing what's also one of the big advantages with Kubernetes is the portability, right? Because now that we cloud is an operating system, it's not a destination, right? So why would we continue to lock ourselves into an RDS or Aurora, which only exists in Amazon, and not just use standard sort of binaries, right? Because that's kind of the question. So where do you see DBaaS going in a world where more and more we are maybe moving infrastructure to Kubernetes?
Well, so I think that the term DBaaS is a very broad term, right? Database as a service. And that is absolutely where I think the industry is moving to, but it's not in what we know it as today. Today, you've got the big vendors, right? Like you mentioned Aurora, Cloud SQL, Azure SQL. These are all some flavor that they've customized to run on their infrastructure well. And that works great if you hire someone who gets trained on those, knows how to do it, and gets you implemented there. And you don't have to leave that cloud, for example. So I think that's still a viable option. But if you ever want to get to a point where you can accelerate and potentially automate your DBAs, you're going to have to look at something else. You're going to have to look at operators or tools that provide DBaaS on Kubernetes, because Kubernetes runs anywhere. And, you'd mentioned that it was a common denominator. I like to think of Kubernetes as the great equalizer.
Sure.
And it equalizes both your data center, your lab setup, and the different clouds. And you can move things across any of those almost seamlessly. If you have a network connection, you can do it. And the tools are there for you to do so. Sure. And so I see more and more vendors creating operators. An operator in Kubernetes is simply a way to codify best practices for that piece of software.
Yeah.
And simplify it in a way to install it onto Kubernetes. So the key thing is an operator in Kubernetes gets something called a reconcile loop, which is every so often and whatever interval, it is reconciling the state of what you asked it to do. And that could be, give me a database that's across 3 continents, that's this big, and it has this level of reliability, let's say.
Yep.
And it can go in every so often and say, okay, let me check the health of these machines. Let me check the storage, capacity. Let me check the networking. And depending on whoever wrote that operator, it could be yourself, it could be a vendor. They will have much more power to fix things for you.
Yep.
And I'm speaking at KubeCon Paris here next week, but there's a lot of AI that can start coming into this, right? Where now you can do the tuning that a DBA used to look at screens. I was a DBA. I used to look at screens for hours and traces and try to figure out where the bottlenecks are. I see a future where that now becomes something packaged in your operator, and they can give you very specific capabilities for your workloads, right? And say, look, here's what we recommend, and even apply it. And so I wouldn't say it eliminates the role of a DBA. I think it elevates and changes it to more of a higher level capabilities, which is training the AI or training or authorizing the operator. And so you're becoming a DBA that manages a team of virtual DBAs that live inside your cluster. So that's kind of where I see DBaaS in the future.
Yeah. So DBaaS as a model, as opposed to when we
DBaaS
talk about
as a
DBaaS,
product.
we think public DBaaS, RDS or Aurora. Yeah. So how do you determine whether to run your database on Kubernetes or VMs or bare metal? Because arguably, it's not going to be the answer for everybody, right? I mean, are there any workload characteristics that that fits its use case? Is it a matter of architectural decisions, right? For instance, migrating maybe to a platform engineering organization, right, for the business with exceptions for legacy?
Yeah, like anything in software, really there is no recipe or silver bullet. Software should not be called engineering because engineering is a blueprint that can be repeated. This is more like gardening, right? And we can garden, and I can take the same seeds that you take and sow them in my yard, but there's different weather capabilities and drought conditions and so on. And so it really is a care and feeding, and that's how software is. And so you can't just say, look, run your database on Kubernetes, period, right? Or run it on VMs, period. You have to look at what you need, whether that potentially could be you have a huge amount of data in your storage that you've chosen that has the particular read-write characteristics or resiliency characteristics, doesn't have a storage interface, a CSI interface that can work with Kubernetes, so you should run it in VMs. In other cases, you might be your application is already built; it's already tied to some technology, and you need that technology doesn't support Kubernetes, so you run it on bare metal. Right? Sometimes they even have specific hardware requirements. If you're greenfield, I think you have the opportunity to look at data differently. You don't have to build a mono database anymore like we used to. And if you see, back in my day, databases, when they started adding JSON or XML or other non-relational capabilities, it was because you had one database and it had to do everything. But now, with the microservices patterns on the application side, we should be looking at micro databases with different technologies to see which one of them is specific for that use case. In that case, the decision becomes a lot easier. The decision becomes, look, I'm now looking at, instead of a terabyte or a petabyte of data, I'm looking at 10, 20 gigs. That's pretty easy. I can put that in this technology in Kubernetes. This other one might be a vector database or a time series database that needs a lot faster storage. Maybe I put that on machines and expose it to my clusters so that my applications can use it. That's, I think, the way to do it, is really to be incremental and iterative and try to look at the problem with the toolkit that you have with you. Do I need something that gives me the resiliency and the scalability, both up and out? Because one thing you can do, and I'm going to take a sidebar, one thing you can do with Kubernetes is you can change the machine that your database runs on. You don't have to have a giant database all the time. And I gave this example, it was right around Thanksgiving. And Thanksgiving in the US, we have Black Friday, which is a crazy shopping holiday. And so you can run your database all year on relatively commodity machines. 2 weeks before, you can scale that up to giant machines, move your application there and your data there, right, for the duration of Black Friday, and then come back down. And so the huge amounts of money that we used to spend on databases in the past, that's not an issue anymore, because we've been able to take advantage of the portability and the capabilities of Kubernetes in our toolkit. So I know I gave you a long answer, and it's not really a prescriptive one, but with architecture, with software, you really have to look at the problem. And like I tell people, my job as an architect is to give you the least amount of technical debt, because there will be technical debt with any decision for your use case. So pick the one with the least amount of technical debt for you.
Yeah. And then it comes to the other side, which is there any time when it is not a good idea, right, to run on Kubernetes? So, it could be organizations with multiple environments, or maybe specific workloads for specific things, or it could even be, competence and supportability, team size, right?
Of course. Of course, of course. If you don't have someone who can manage your Kubernetes, or you're not purchasing Kubernetes as a service, you should not use it.
Right.
Absolutely not. If you have a requirement to run on special hardware, don't try to put shim Kubernetes in there, right? There are a lot of other options that you can run your databases on, all the way from bare metal to virtual machines to other virtualization technologies and orchestrators and Kubernetes. But there are absolutely cases where you should not use Kubernetes, and that could be slowing down your databases. It could give you, if it's not configured correctly and you don't have the right administrators, it can actually lose your data.
Yeah.
So you want to make sure that you have all of the checkboxes from that side before you decide to put something on critical like your data in Kubernetes.
Yeah. I mean, I still remember some of those, horror stories of, I changed the name of the database and suddenly Kubernetes was reinstalling the database, or, I changed a couple of configuration parameters. So I guess it's like a sharp knife. You can be very efficient with it, but you can also,
and that is a very real scenario that happens every day, especially with this platform engineering discipline that's starting to happen, where you give a little bit more self-service tooling to your end users, your developers, and they think of changing of a name as a simple thing, and that'll reinstall their services, right? And that'll fully uninstall everything, reinstall it, because that was the key that it was using to determine the state. And if that key has changed, it's a different application. So you get away with it when it's stateless. You can't get away with it with data.
No. So, in terms of scale and cluster size, is it not a limiting factor? I read somewhere a cluster of up to, 5,000 nodes, 110 pods per node.
Yeah, it is. It's still a factor. I used to be an advocate of these gigantic clusters. I thought it was cool to have the world's biggest cluster. In my previous job, that was kind of where we started. But the more and more that I have had experience with Kubernetes, I'm a much more of an advocate for micro clusters. You're starting to see a theme. Everything is micro services, micro databases, micro clusters. Your blast radius is smaller, and we have the technologies now to effectively mesh these clusters together. So you can have a virtual cluster of 1,000 nodes, but you also have multiple control planes. That is the bottleneck. Is you have a control plane that sits on top of your machines that controls where everything goes, how the networking works, the DNS, the security policies, and so on. There is a limit. There's always going to be a limit to how many machines you can manage and how many pods. So break it up. Let's have the now that we can have these clusters anywhere, we can plumb them together, whether you're using a service mesh. You can use things like Cilium. You can use things like Linkerd. You can use things like Scupper to create these virtual networks, these effectively programmable VPN tunnels, and take advantage of whatever dedicated network you have and connect them together. So I'm more of a fan of that. But you're absolutely right. You can absolutely hit an upper limit on your cluster size. And I think that's the case with any technology.
Yeah. I mean, it's interesting. I picked up on the blast radius comment, right? Because looking a little bit at how how infrastructure is being consumed in the world, a lot of infrastructure is concentrated with the hyperscalers. And, we all read in the news pretty much every week that, this went down and thousands of services were taken down.
And you should really get yourself or your folks trained on understanding composite SLA and how to measure that. Because a lot of the hyperscalers, they have very strict rules. Like, we'll give you 3 nines if you're in these 3 regions, and each of them together are this 1 9 or so on. And so there is a way for you to, if you ever have a 4 nines or 5 nines application, you can achieve it, but you can't achieve it in one region or in one hyperscaler. That's just not, there's no way to do it. And so there's a simple formula. You have to figure out how many 3 nines regions you have to be in to give you the 5 nines, and it's 3. Sometimes if you want higher than that, you have to go to 4. But now you're talking about active, right?
Yeah.
And so on. And that's where these technologies come in. That's where I think microclusters and these cluster meshes really show their power, where you can create effectively, 4 small database clusters, mesh them together, add replication factors across it. So if you lose, what is it? It's almost 9 o'clock. So US East 1 is going to go down, scheduled, failure every week or whatever. You can have the backup and your data doesn't go away. That's kind of what once you have these tools, you can really start playing that game and providing a better service for your customers.
Yeah. So, the only issue I would say when we talk about multi-cloud, multi-region is the cost. Even take the egress costs, it can get pretty hairy unless you have some kind of good deal.
Yeah. I mean, egress is one. I think egress is probably not the biggest cost. I would say compute is a bigger cost, but I love playing that game with the different vendors when I am not tied to them, and it's just like so I'm Egyptian originally, and we love to haggle. And so one of the best things you can do to someone at a store, at a vendor, you can go and say, "You're going to give me this price, or I'm going to walk away." And you start walking away, and they do that with your vendors. Now that you can do that with the multi-cloud, do that, and they will give you some deals. Hopefully, I don't get blacklisted by anybody watching this, but that is the capability that you have. You have no more vendor lock-in. You have the power now to negotiate.
Yeah. So moving into kind of nuts and bolts here, we talk about operators, and that's as a way to extend the functionality of Kubernetes. And all the database vendors have released their own versions. And looking at the operators out there, the question is, do they provide everything you need to actually run your database, right? I mean, day one, to make sure that you have proper deployment with monitoring and alarming and all that. And then day two with backups, upgrades, scaling. Or maybe you have to fork it. And what does that entail when you do that?
Yeah. So, it's a software product, and all the software products aren't created equally. And you really need to look at your vendor and the technology that they're providing, because for each technology, there's multiple operators. And each of them have a different definition of day two, right? So yeah, they're probably all going to give you day one. They're going to give you the monitoring and alerting and the installation and the networking and all that stuff out of the box, right? And some will just shake your hand and say, "We'll see you later." And others will take it to the next step and do the day two. So you need to do your due diligence there if you're going to pick a vendor, just like you would with any other software product that you would buy. Forking is never a good idea, because it's hard to keep up with the upstream. Especially some of these vendors are really quick, really, really fast moving. I would say if you have the capability, if your company allows it, contribute to that product rather than forking it for yourself. As soon as you fork it, you stop getting the upstream upgrades and the changes. So I would advocate for contribution. I'm a big open source software advocate, and I love contribution. I would say that's the better path than forking it. Then you can build it yourself, right? If you have the expertise in-house with that database technology, you can implement that framework yourself and really custom tailor it for what you need if you have special day two requirements. So you can have it installed with the vendor operator, and then your operator takes the day two portion, whether that's you're doing special kinds of backups or you want to replicate in multiple regions or whatever. That's something you can do as well. But so that it's not an easy answer, but I would say just treat it like any other piece of software. Treat it like you're interviewing a DBA, and you want to know the capabilities and the capabilities of that person or software, and then decide if you want to install it. And the good thing is you can start small.
Yeah.
This Kubernetes can run in your local home lab. You can test it and see if it satisfies what you need before you take it out into production.
Yeah. The thing is, then you need to know Golang. I guess that's
No, not at all.
No.
So that Golang is probably the biggest, the mostly used language in Kubernetes. But we, for example, write everything in C# and .NET. And there's some great .NET and even Java frameworks and Rust frameworks that let you implement the operator, because the operator is just a container that you deploy into Kubernetes, and you specify types and you extend the API, and then you can call it. So whatever capabilities that you have from a development perspective, you can build an operator on. And that's the great thing. Another thing about the equalizing capabilities of Kubernetes. If you're a Java shop and you have hundreds of Java developers, one day, there was the concept of a SQL developer where you had your developers understand SQL. Take that, put it in an operator written in Java and deploy it. And now you can take that expertise and do it. Most vendors, I would say, probably use Golang. So you would need to know Golang for that. Some do Rust for like the really high performance stuff. But again, it's just like interviewing a DBA or a software developer in your company. Are they a fit, right? If you're going to contribute to it, or if you're going to install it, do you understand how to look at crash dumps from Golang or .NET or Java? Those are kind of the things you need to look at as well.
Yeah. So is an operator the only way to run a database on Kubernetes? Or, you talked about stateful sets.
Yeah. I mean, it's not. It's a means to automate the installation. There are a lot of databases that are installed with Helm charts. Some are installed with just vanilla manifest and vanilla YAML file. At the end of the day, something is going to need to give Kubernetes YAML, right? It's objects. Now, in Helm, that's a templating package that lets you give it some variables and it'll create that and do it. And that's a once and done. That's kind of like, hey, we installed it, we set it up for you. Thank you very much. See you later. Operators ultimately create the same manifest, but then they have that loop where they can go back and they can start updating it. So you can do it other ways. I would recommend going with operators. I think operators are the way that give you that day two, right? Capabilities. It could be a group of operators. Sometimes there's operators that create cron jobs for backups, that create, other operators to manage a different life cycle of it. I think operators are the way to go. It's not the only way, but I think it's the way to go.
Yep. Yeah. So we touched on portability, and we generally agree that it's something that is considered important, right, among organizations. When talking about Kubernetes, different cloud vendors, especially, they have different, varying levels of conformance, right? API compatibility, feature support. Then you have your on-prem platforms, right? You have that in maybe your OpenShift, in OpenStack, you have some other components, Magnum, to do that. So, so ideally, you want to run applications in as standardized environment as possible, right? Images in a repo, standardized software, Helm charts, right? But is it a case of, write once and debug everywhere, right? How portable is it really across all these different, let's say, Kubernetes installations, different environments?
Yeah. So Kubernetes is a unique piece of software. And I think it gave everybody the opportunity to come to the table and play. That's why competing companies are adopting Kubernetes and contributing to the project. And that started giving us drift in the very early days. Like you said, Amazon's version is very different than Google's version, very different than AWS version. But thankfully, the CNCF, which is the kind of the governing organization, the foundation around it, has started creating certified Kubernetes distributions. And that gives you kind of the baseline. This is, it'll work. It's certified Kubernetes. It'll work with your vanilla Kubernetes, whether that is your home lab, whether that is like a Tanzu, or whether that's AWS, so on and so forth. So with that, there's some level of conformance, right? You can You're still not going to be able to build once and deploy everywhere or debug everywhere, but you're going to tweak very minor things. And concepts like I was mentioning in my talk, things like storage classes, that's a simple abstraction that the vendor can create. And now you can basically talk to storage, fast storage, without having to know the details of the EBS or EFS volume or the Azure tables that are underneath or the storage disks or whatever. You can just tell your manifest, I want this kind of storage class, the default or whatever. Same with networking. Networking is very different. CNI is a huge topic, and it can vary from one to another. But you have things like kubedns, and you have services that live on top that give you that standardization across it. So there was a really good model introduced back in I think it was 2017 called the Open Application Manifest, OEM. Sure. If you go to oem.dev, they kind of break out the roles into 3 separate areas. So you have infrastructure operators. So those are the people that are focused with the infrastructure and configuring that. You have the application operators. Those are like your SREs that configure how many replicas and so on and so forth. Then you have the application developer. So if following that, you can truly build 75% once, and then the last 25% is the variations between the different environments, and that could be handled by another team, a platform engineering team or your ops team. So you're still gonna have to debug everywhere, right?
Yeah.
That's kind of the that's the given with any piece of software that you write, even data, because of the quirks. So you're gonna need that 25% to be really good at their job. But now that 25% is not with every single team. That at least can be optimized for your organization that way.
Yeah. And I guess it takes some skill to make sure it's organized so that it's only 25%.
Yes, exactly.
Because if it's all over the place, then you're going to take more time.
Yeah, that's where things like platform engineering really evolved from. We had DevOps and people started looking at that, and there was a divergence, I would say, towards SRE and DevOps. And you realize that you had these teams that had the same kind of people doing the same work across the board, and they weren't collaborating, right? You had an SRE engineer or somebody. Every team had a Kubernetes expert who was a little bit different than the other Kubernetes expert, and you ended up paying extra, right? Whether that's time or physically, resources. And you weren't seeing that benefit. Platform engineering kind of came in and said, hey, why don't we take all these folks that are building the common tool sets and the tool chains and provide that as a service, right? Platform engineering as a service internally. Yep. And, the big poster child of platform engineering is your internal developer platforms, your IDPs, that are like your portals that say, here's everything that we offer. You can pick and choose and kind of index your stuff there. You need a cluster, we'll give you a cluster. You need a storage array, here's a storage array. And it's the experts in the company that have come together. That's when you can start seeing some of the efficiencies.
Yeah. So transitioning and looking a little bit more, future, what next, right? Where does Kubernetes go? First, let's say more broadly, and then for maybe stateful, workloads. Will we see more organizations like for example Starbucks, right? Basing their internal, database as a service on Kubernetes. For public DBaaS, we have MariaDB SkySQL. We have EDB. Big Animal is called, right? Mm-hmm. So where do you see things, going?
Well, I definitely see Kubernetes getting into many, many more areas, right? And we've seen it put in cars now. They have clusters in cars. They have clusters on airplanes. You have clusters in fast food chains, and they're absolutely running the applications on their edge clusters, if you would. And I absolutely, they already are putting databases on there, but I think it's going to get a lot more, to be the norm, where you're going to start seeing these databases, even if it's local store, right? The local storage that you have, they're going to be put in a Kubernetes, and that might potentially then be set up into higher and higher levels of warehousing that could be in the cloud. So I think what we're going to see with the geopolitical, events that have been happening over the last 2 years, and then a lot of the new security things that are coming, right? There's just an AI law that was passed in Europe. NIS2 is happening with the vulnerability indexing and the SBOM. Same with in the US around executive order. Just yesterday, there was a bill passed by Congress about TikTok and who owns it, right? So the world is shifting away from I just put it in the cloud. Well, whose cloud is it and who has access to it? So I think there is going to be a lot more cloud players in the future. I think Kubernetes is going to take a top position there because nobody wants to build their application to work on one cloud that may not be there or may not be available for me to service my customers. And so definitely a big application push on there, but data has to follow. Data is probably the biggest, red line in any of these components, in any of these laws or regulations. Where is my data stored? AI is becoming highlighting data even more. Now we need to be able to see it. Kubernetes is going to give you the ability to abstract it, show it, and add monitoring capabilities on top that maybe you didn't have before. I think it's going to be a first-class citizen by the end of this decade.
Yeah. So what we need to get there is, from the community and vendors. I mean, we need, as you mentioned, first-class citizenship. Then there's more development there needed. And I mean, I don't know if you take an allusion to OpenStack, because OpenStack grew into this gigantic kind of thing with, I don't know, vendors maybe pushing in different directions. How do you see what's needed for Kubernetes? And, if in a way there is a risk to fall into this gigantic OpenStack.
I don't think Kubernetes necessarily is going to be the highlight there. I think there's going to be standards that are going to be highlighted, whether that is things like SPIFFE or OTel, OpenTelemetry, for example, things that are going to start standardizing where the customers are going to say, look, I've already got 95% of my stack monitored using this, this tool. Why can't I look at my database? Why do I have to buy this bespoke product? Or, or hang on a second, I've got all the security policies. Why do I have to go learn another language to go, I want to use Regos, whatever, right? I think that's where we're going to start seeing the push probably in the latter half of the decade, especially with AI and especially with a lot of these tools that are coming out. And I think operators are going to start becoming more mature. You're going to start seeing things that are, look, we can run it on Kubernetes. We're going to give you day two. We're going to give you the auditing. We're going to start raising security alerts based on your data. We're going to start showing behavioral pattern matching on your queries and so on and so forth. And that's going to be where the competitive angle is going to be. Because if your organization is going to invest in Kubernetes and they're going to hire people that understand it and care and feed for it, I want to put my data on there. Why not? I just invested this huge sum of money. And so I think the vendors are going to see it. I think we're going to start, there was an effort a long time ago with ODBC, right? Or JDBC, which was a kind of universal language for databases. I don't know if that's going to happen. I think it would be nice to have it instead of everything being Mongo wire compatible or Postgres wire compatible. That's effectively a standard, but it's an unwritten standard. I think we're going to start seeing some stuff from the CNCF, maybe some other foundations as well, start becoming, the winners. And I think when there's a lot of competition, it pushes it all to a better place, and then eventually maybe one wins, right? We saw that, we have all the different telemetry providers. Now they all are standard on one standard. And so maybe we'll see something like that for data. I don't know, but I'm really excited to watch the next 6 years and see what happens there.
Yeah. So to summarize, Eddie, what would be your recommendation to enterprises when it comes to devising a new, Kubernetes-based database strategy?
Yeah, that's always an interesting one. I would say, look, Kubernetes is here to stay. Invest in it. Invest in your people that you have. Have them understand the capabilities of the tool, and not necessarily how to be experts at it, but the capabilities. And then from there, look at your software. Just like we had the shift from it being, just an enabler of, some processes to being the business, right? Your data is now in that pool. So look at it in the same way that you look at your applications. It's always an afterthought in organizations. Look at that and see how can it fit with the general Kubernetes landscape that you have, so you can get the efficiencies there. But also keep in mind that it may not fit or may not be exactly the right fit in that Kubernetes. So keep an open mind. You don't want an organization to ever say, this is it and we're going this way, period, one way or the other, right? Look at it as a tool in your tool belt, figure out what the best use is, educate your folks on it, and keep up with the whirlwind that's going on in the cloud native space. Because Kubernetes is really going to give you that freedom to pursue your customers wherever they are and deliver a product that is effectively, to put it another way, nobody's paying you because you're the best at CI/CD or you're the best at, orchestrating VMs. People are paying you for your product. So take advantage of what's already out there that can help you make your product the best that you can make it.
Yeah. Okay, excellent. Well, thank you, Eddie. It's been great talking Kubernetes with you. Wise words there. And folks, that's it for today. So see you all for the next episode. Thank you.
Thank you so much. You have a good one.